Hello everyone. Today we are going to learn optical isomerism. In that optical isomerism, we will study enantiomerism, diastereomerism, meso compound, and racemic mixture. So let's start optical isomerism. Isomer which rotates the plane polarized light to right or to left are called as optical isomers, and the phenomenon is called as optical isomerism. Optical isomer must having the chirality. So what is chirality? Chirality in Greek language chair word means hand, hence the molecule which is non-superimposable on its mirror image is said to be chiral, and the term chirality means showing handedness. So all the chiral compound having different optical isomers. It can be understood by the enantiomer. In this figure, you can see our hand, left and right hand are mirror image to each other. So this left and right hand does not superimpose to each other. But in this object, bottle, it is a mirror image to each other, but it can superimpose. So it is a achiral and it is a chiral. Now, enantiomerism. Enantio means opposite and mer means part. So what is the definition of enantiomerism? Isomer which having a non-superimposable mirror image to each other are called as enantiomers, and the phenomenon is called as enantiomerism. In this molecule, you can see A and B are mirror image to each other, and this mirror image, if we rotate a molecule by any orientation and if we superimpose to the B, it cannot superimpose. So that's why it's called enantiomer. So you have to remember always enantio means opposite, means mirror image to each other and which are non-superimposable to each other. First enantiomer observed by Louis Pasteur in 1848 in tartaric acid. They discovered a salt, sodium ammonium tartrate. They crystallized and they observed enantiomerism in that sodium ammonium tartrate salt. This is the crystal of tartaric acid. One is a dextro, another is a lead. Tartaric acid having a 2 chiral center. This is a 2 chiral center, and both having a same property except specific rotation, and they are non-superimposable to each other. Now, properties of enantiomerism. Physical and chemical properties. They have identical physical property except specific rotation, and identical chemical property except reaction with optically active reagent and compound. You can see here, this is the levo and this is the dextro. Melting point, solubility, then densities are same in both enantiomer. Only difference is specific rotation. One is a Leo and another is a dextro. Now, biological properties of enantiomer. They have a different biological properties. Specific enantiomer binds to particular binding site. can see here this one enantiomer, this another enantiomer. The one enantiomer bind easily to this binding site, but its mirror image does not bind to its mirror image. By any rotation of that mirror image also does not bind to this mirror image. So that specific enantiomer binds to particular binding site. Here is some example that shows the different biological effect of particular enantiomer. Here is DOPA. D enantiomer is a inactive and L enantiomer having a anti-Parkinson. Thalidomide, R enantiomer reduce the morning sickness in a pregnant woman. S enantiomer having a side effect of teratogenic and birth defect. Ibuprofen R enantiomer is a inactive and S enantiomer having a anti-inflammatory activity. So we concluded that particular enantiomer gives a particular activity. One enantiomer may be active or another enantiomer may be inactive. Now, meso compound. Compound which having a one part is a mirror image to other half part at middle is called as meso compound. Now meso compound. Compound which having a one half part is mirror image of other half part at middle is called as meso compound. Meso compound are achiral even though it contain a chiral carbon. Meso compounds are optically inactive due to its having a plane of symmetry. In this example, enantiomer are chiral and meso compounds are achiral because it is having a plane of symmetry. Even though it contain a chiral carbon, it having a two chiral carbon. But these two chiral carbon having a opposite optical activity. One may be a LEO, another may be a dextro. So it cancel out each effect of chiral center. So it is a optically inactive and it become a achiral. In another example, 2,3-dichlorobutane and in this cyclic compound, it is having also a plane of symmetry. So it is a meso compound even though it contain a chiral center. Now diastereomer. Stereoisomers of a substance that are non-mirror image of each other are termed as a diastereomer. Means diastereomer which are neither mirror image nor superimposable. Here is example. Here is a two pair of enantiomer. Here is a total 4 stereoisomer. You can see diastereomer 1 and 3 are diastereomer. 1 and 4 are diastereomer to each other. 2 and 3 are diastereomer to each other. 2 and 4 are diastereomer to each other. So in that diastereomer they require minimum 2 stereo center. They have different physical properties like melting point, boiling point, solubility, density and refractive index. They have also different chemical properties. Diastereomers have a different specific rotation but they may have a same or opposite sign of rotation. Now racemic mixture or racemic modification. A mixture having an equal amount of enantiomers is called racemic mixture or racemic modification. A racemic mixture or racemate is one that has equal amounts of left and right handed enantiomers of a chiral molecule. The first non-racemic mixture was racemic acid, which Louis Pasteur found to be a mixture of two enantiomeric isomers of tartaric acid. Racemic mixtures are optically inactive due to cancel out the opposite rotation of each enantiomer. A racemic mixture is denoted by a prefix plus and minus or DL. For sugar, it represented by capital DL, indicating an equal mixture of dextro and leo isomer. Also, the prefix symbol RS or SR are used. So, dear learners, I think you understand as optical isomerism in that you have studied enantiomerism, diastereomerism, then meso compound and racemic mixture. So, in this optical isomerism, you have to remember always enantiomer and diastereomer are optically active compounds, while meso and racemic mixtures or racemic modification are optically inactive